Yeah. So good evening, everyone. I am Neelav Bhatiya. I have currently completed my third year from Sardar Vallabhbhai National Institute of Technology in the Department of Computer Science and Engineering. मैंने अपना 12th 2020 में खत्म किया था. It has been 3 years since then, and I got a rank of 1755 AIR 1755 in JEE mains, and that's about it. So today we are going to discuss trigonometry's third chapter from the NCERT book. और ये चैप्टर ट्रिग्नोमेट्री के बेसिक इंट्रोडक्शन से चालू होता है एंड देन इट टॉक्स अबाउट जिसमें क्या क्या आइडेंटिटीज इन्वॉल्व होती है, क्या क्या फॉर्मूलाज इन्वॉल्व होते हैं, और इसके पर्टेनिंग इस चैप्टर में एक्सरसाइज है. ये चैप्टर बहुत इंपॉर्टेंट है क्योंकि इट बिल्ड्स अ बेस जिसके जिसके ऊपर आप ट्रिग्नोमेट्री आगे सीखते हैं इन योर 11th एंड कॉन्सिक्वेंटली इन योर एंट्रेंस एग्जामिनेशंस एज वेल. सो इस चैप्टर का एक अच्छा बेस होना बहुत इंपॉर्टेंट है जब भी हम कोई एंट्रेंस की तैयारी कर रहे हो या अपने बोर्ड्स की भी तैयारी कर रहे हो. इट्स वेरी इंपॉर्टेंट कि इस चैप्टर का अच्छा बेस अपने पास क्लियर हो. सेकेंडरी थिंग दैट आई वुड लाइक टू पॉइंट आउट इज ये चैप्टर में अच्छे मार्क्स स्कोर करना ये चैप्टर के क्वेश्चन सॉल्व करना इज डिपेंडेंट अपॉन कि आपके इज डिपेंडेंट अपॉन एक्चुअली टू थिंग्स कि आपके कंसेप्ट्स, आपके बेस कंसेप्ट्स रिगार्डिंग ट्रिग्नोमेट्री, कैसे आइडेंटिटीज आई, कैसे आपकी ट्रिग्नोमेट्रिक फंक्शंस होते हैं, कितने क्लियर हैं और आपने कितनी प्रैक्टिस की है. अगर आपके कंसेप्ट्स क्लियर है और यू हैव प्रैक्टिस्ड ऑल द प्रॉब्लम्स फ्रॉम एनसीईआरटी एंड और एक कंसेप्ट बुक से, then you shouldn't have any problems, you shouldn't face any problems regarding the questions from this chapter. So without wasting any more time, let us actually start with the exercises from NCERT and kind of go about solving them, right? Let us start that. So the first question is that is asked of us in exercise. We are going to first of all start with exercise 3.1 and उसके क्वेश्चंस हम आगे सॉल्व करेंगे जिससे हमें अच्छा अपना अंडरस्टैंडिंग आएगी ट्रिग्नोमेट्रिक चैप्टर की रिगार्डिंग, राइट. सो एक्सरसाइज 3.1 में क्वेश्चन नंबर 1 states that find the radian measures corresponding to the following degree measures. इस क्वेश्चन में हमें सारे जो भी एंगल्स दिए हैं दे आर इन द फॉर्मेट ऑफ डिग्रीज और हमें पूछा गया है कि आप इन कंसिक्वेंटली इन डिग्री मेजर्स को आप रेडियंस में कन्वर्ट कीजिए. तो जब भी यू वांट टू कन्वर्ट अ डिग्री मेजर टू अ रेडियन मेजर, व्हाट यू आर रिक्वायर्ड टू डू इज आपको उस नंबर को बाय फैक्टर ऑफ पाई ओवर 180 से मल्टीप्लाई करना है, क्योंकि वी नो दैट कि जब भी आप हाफ रोटेशन कंप्लीट करते हो आपका एंगल 180 होता है इन डिग्रीज और आप पाई रेडियंस कवर करते हो, राइट. दिस इज द बेसिक अंडरस्टैंडिंग दैट वी हैव, करेक्ट. सो लेट अस ट्राई एंड सॉल्व सम ऑफ दिस क्वेश्चंस. So the first question's first part is convert 25 degrees into radians, right? So let us multiply 25 by a factor of pi over 180 as we have discussed previously. So 25 into pi over 180. यहाँ पे will cancel out by a factor of 5. यहाँ पे 5 बचा, यहाँ पे 36 बचा. So the final answer that we get is 55 over 36. Correct. Now moving on to the next part. Next part asks of us कि आप -47 डिग्रीज 30 मिनट्स को रेडियन में कन्वर्ट कीजिए, राइट. सो एक मिनट में वी नो दैट 1 डिग्री इज इक्वल टू 30 मिनट्स, करेक्ट. सो दिस 30 मिनट्स could also be represented as half a degree, करेक्ट. सो इसको अलग तरीके से लिखने का फॉर्मेट होगा 47.5 degrees. And when we have converted the degrees into a decimal format, हम इस नंबर को वापस पाई ओवर 180 के फैक्टर से मल्टीप्लाई करेंगे जिससे हमें आंसर मिल जाएगा, करेक्ट. सो -47.5 into pi over 180 equals let us write -47 as minus 95 upon 2 into पाई ओवर 180 और जब हम ये सॉल्व करेंगे तो फाइनल आंसर दैट वी गेट इज -19/72 pi. This is our final answer. Correct. Let us solve one more part in this question. Right. टू 40 डिग्रीज इसको हमें रेडियंस में कन्वर्ट करना है तो अगेन वी मल्टीप्लाई इट बाय फैक्टर ऑफ पाई ओवर 180 सो 240 into pi over 180 यहाँ पे we can cancel out by factor of 60 4 is remaining 3 is remaining the final answer that we get is 4 pi by 3 correct this is our final answer. Now, the next part is we need to convert 520 degrees into radians. Correct? Again, we multiply by a factor of pi by 180. So 520 into pi by 180 is equals to, and when we cancel it out, what we are remaining is, we can cancel it out by a factor of 9 actually. So by a factor of 20 actually. So we are left with 9 here and 26 here. And what we are left with is 26 pi over 9. This is our answer in radians. Correct. So the first part, actually the first question in exercise 3.1 was very simple. ये बहुत simple था. हमें करना था कि हमें सारे डिग्री मेजर्स को रेडियन मेजर्स में कन्वर्ट करना था और वी हैड अ फॉर्मूला फॉर दैट. हमें सीधा pi by 180 के फैक्टर से मल्टीप्लाई करना था and we got our answer. Let us look at the second question with जो हमें इसका इनवर्स फाइंड आउट करने के लिए बोलता है, राइट? जब हमें जो एंगल है उसका मेजर रेडियंस में दिया होगा, वी नाउ नीड टू कन्वर्ट इट इनटू अ डिग्री मेजर. करेक्ट. So that is our second question. Let's move to that. So question number 2, first part is find the degree measures corresponding to the following radian measures, right? So the first part में हमें radian measure जो दिया है, that is 11/16. Correct. Now रेडियन मेजर को हमें डिग्री मेजर में कन्वर्ट करना है, तो वी नीड टू मल्टीप्लाई बाय रिवर्स ऑफ द फैक्टर दैट वी वर यूजिंग इन द फर्स्ट क्वेश्चन, राइट? फर्स्ट क्वेश्चन में हम पाई बाय 180 के फैक्टर से मल्टीप्लाई करते थे. सो इन द सेकंड क्वेश्चन हम 180 बाय पाई के फैक्टर से मल्टीप्लाई करेंगे. करेक्ट. सो 11/16 into 180 over pi. Correct. And when you simplify this, what you are actually, let us try and simplify this first. So either we can cancel by factor of 9 and we can then also cancel by factor of 2 again. So what we are left with is left with this 45 into 11 upon 4 into pi. Correct. Let us convert pi into 22/7. So we get our answer in degrees. Correct. So 45 into 11 4 into 22/7 यहाँ पे by 7, right? यहाँ पे you can cancel 11 and 22 and what we are left with is 45 into 7 by 8. Correct. And when you do this calculation, what you're left with is 39/3/8 of degree. So that is how we solve. Correct. कुछ नहीं करना. It is a very simple thing to do. Just 180 by pi के factor से multiply करना है and that is how we get the answer. Correct. इसको this answer you can also convert it into minutes and seconds. अगर इसे seconds into and minutes में convert करना है तो the procedure is very simple, right? हमें क्या करना है? हमें कुछ नहीं करना. हमें first calculate करना है कि 1 डिग्री 60 मिनट्स के इक्विवेलेंट होता है, तो 38 डिग्रीज कितने मिनट्स के इक्विवेलेंट हुआ. करेक्ट. सो व्हाट वी नीड टू डू इज मल्टीप्लाई दिस इनटू 60 डायरेक्टली एंड जब हम वो करेंगे तो विल गेट द आंसर एज 30 39 degrees, or when you do this calculation, the answer you will get is 22.5 minutes, right? So we can also represent this answer in this format, but that is not required. अगर आप 39 degree 38 degree लिख के आएंगे, तो that is also the correct answer, right? Let us move on. Now we need to convert -4 into a degree measure, right? So again, we multiply by a factor of 180 over pi, correct? And when you simplify this, you get, let us expand, let us write pi as 22/7. And when you go on to solve this, what you'll get is minus 229 degree, minus 229 and 1/11 degree, correct? This part of the answer, इसको आप वापस minutes और seconds में represent कर सकते हो, but the process there is very simple. So I will not diverge into that, and we'll go on solving more questions. But जैसा मैंने आपको इसके पहले के question में explain किया है, if you want to convert it into minutes and seconds, it's very easy, right? It's something that you can do very easily. And now moving on to the next part, what we are left with is question 2. We are on the question 2's third part now, correct? Now we need to convert 5 pi by 3 into degrees, correct? The process remains the same. हमें क्या करना है, 5 pi by 3 को 180 by pi के फैक्टर से मल्टीप्लाई करना है. Pi and pi gets cancelled. 3 into 60. This gets simplified. This gets simplified. This is 3. I'm sorry. This 3 to 60 gets simplified. 60 into 5 is 300. So it is 300 degrees. Correct. Very simple. Moving on to the next part. Seven pi by 6. This is also required to be converted into degrees. So we do that again. 7 pi by 6 को आप 180 by pi के factor से multiply कीजिए, correct? Pi and pi gets cancelled. 6 into this gets reduces to 30, and 30 into 7 is 210, correct? So 210 is your answer. Moving on to the next part. Now question number 2 of this exercise is over. We shall move on to the next part, correct? Sorry. A wheel makes 360 revolutions in 1 minute. Through how many radians does it turn in 1 second? Correct. So this is a question that is asked of us. एक जो wheel है वो 1 मिनट में, क्वेश्चन नंबर 3, 1 मिनट में 360 revolutions कंप्लीट करता है, राइट? वी नीड टू फाइंड आउट कि 1 सेकेंड में what is the angle measure in radians that it turns by, correct? So to do that, first let us find out कि 1 सेकेंड में ये wheel revolution 1 सेकेंड में कितने करता है, because the measure that is given to us is that वो 360 revolutions 1 मिनट में करता है, but let us convert it into revolutions per second, correct? So 1 minute is equivalent to 60 seconds, right? So 60 seconds में it does 360 revolutions. So 1 second में it does how many, right? Simple maths here. We just need to cross multiply. So x, let x denote the number of revolutions that it goes through in 1 second. We get x by dividing 360 into 1 by 60, correct? So this cancels out and we get 6 revolutions per second, correct? Let us try and remember this. So it does 6 revolutions in 1 second. We know that in 1 revolution, a wheel covers a degree measure of 2 pi radians. Correct? So when it does 6 revolutions, what is the angle right here? Again, we need to cross multiply and find out the answer. Correct? So in one revolution, it covers 2 pi degree in radians. So in 6 revolutions, it covers x, and we get x by 6 into 2 pi over 1, and this gives us the answer as 12 pi radians. Correct? So that is how we solve this question. Find the degree measure of an angle subtended at the center of the circle of a radius 100 centimeter by an arc of length 22 centimeter. Correct? So before we solve this question, one formula that we might have learned before that we need to remember to solve this question is angle subtended by an arc at the center of the circle theta in radians is given to us by the length of that particular arc divided by the radius of the circle. Correct? So the simple formula that we can remember is theta equals to L upon R. Correct? That is the angle in radian that an arc subtends at the center. Correct? But we need to find out the degree measure of the angle, right? So whatever the theta that we get here, we just multiply that by a factor of 180 over pi, as we have discussed in the questions previous to this. Correct? So this is the formula that we are going to use to find out our answer. Correct? Now all that is remaining is we need to plug in the values in this equation. Correct? So L, the length of the arc that is given to us is 22 centimeter. Correct? The radius of the circle is given to us as 100 centimeter. 180 remains as is, and pi reduces to 22 into 7. Correct? So 22 and 22 gets cancelled. We also reduce this, and when we solve this, we get 12 3/5 degree, or if you convert this into minutes, you get 12 degrees and 36 minutes. Correct? So that is how we are going to solve this question. इसके आगे भी जो question आएंगे, the question that proceeds now are going to be based on this particular formula only, right? So question number 5. In a circle of diameter 40 centimeter, the length of the chord is 20 centimeter, right? Find the length of the minor arc of the chord. Correct? So let us first try and visualize कि ये question हमें बताना क्या चाहता है. Correct? Let us draw a circle. Correct? यहाँ पे let this represent the center of the circle. So we are told that this particular chord is 20 centimeter. Correct? The radius of the circle is given to us as 20 centimeter as well. Correct? So this is also 20 and this is also 20. Correct? Now the interesting thing to note here is all the sides of the circle of the triangle, are equal in nature. Correct? All sides are 20 centimeters long. So this by observation is an equilateral triangle. In an equilateral triangle, the measure of each and every angle inside the triangle is the same and equates to 60 degrees. Correct? So we now know that the angle that this chord subtends at the center is theta, and that theta equates to 60 degrees. Correct? Now we have found out the radius of the circle. We also have the angle that the particular chord subtends at the center. Correct? All that is required of us is we need to find out the length of this minor arc. Correct? So we'll apply that formula once again. Theta equal to L upon R. We know the theta that is given to us. we know L. We also know, we don't know actually, we don't know L, we know R. So we have two unknowns and we have two knowns and one unknown, and we'll be able to use this formula to solve the question. Correct? So L equals to theta into R. Theta is given to us as 60 degrees, which we have found out by observation because this is an equilateral triangle, right? Represent that in radians. In radians, 60 degrees pi by 3, correct? And the radius of the circle is 20, correct? So the length of the arc would then equate, we'll denote arc by this symbol right here, 20, so sorry, denote 20 into pi by 3, right? So the length of the arc is 20 pi by 3 centimeters, correct? So we have found that out, correct? Sorry, this is 3.1. Let us discuss the next question, question number 6, right? If in two circles the arcs of same length subtend 60 degrees and 75 degrees at the center, find the ratio of their radii. Correct? This is the question. So the length of the arc, let us denote that by L. This length is same in both the circles, circle A and circle B. This length is the same. Correct? This is not changing, right? So we know that theta, that the angle, that is the angle that is subtended by uh, by the by the chord at the center would equate to L by R. Correct? We can also represent this as L equals to theta R, because the angle, because the length of the arc in both the circles is the same. So we can write L as theta 1 R1 and also as theta 2 R2, where theta 1 and R1 represent the angle and radius of the first circle, and theta 2 and R2 represent the angle and radius of the second circle, correct? So we can now equate both the quantities because हमें बोला गया है कि arcs of both the circles are of the same length, correct? So we'll now do that. So we now have theta 1 R1 equating to theta 2 R2. Now all the values are given to us and we are asked कि R1 and R2 का ratio find out करना है हमें, right? So theta 1 is 60 degrees. 60 degrees in radian can be represented by pi by 3, correct? R1 is equal to theta 2, which is the angle on the second circle, that is 75 degrees. That can be represented in radians as 5 pi by 12, correct? So 5 pi by 12 R2. Pi and pi gets cancelled from both the sides. 3 gets reduced to 4 and R1 by R2 comes to be 5 by 4. All right. So this is the ratio of this radii of the first circle and the second circle. Our question here is solved. Find the angle in radian through which a pendulum swings if its length is 75 centimeter and tip describes an arc of length 10 centimeter, 15 centimeter and 21 centimeter. Correct? So again we have to apply the same formula. Theta equals to L by R. In the first part, the L is given to us as 10 centimeter. Correct? So theta 1 is equal to 10 upon 75 and this is the radian of the first angle, radian measure of the first angle, correct? By simplification we can also write this by this as 2 by 15 radian, correct? So the first part of the question is solved. Let's move on to the second part. Question 7. So the second part is, if it subtends, if the tip marks an angle, if the tip goes over an arc of 15 centimeter, we get theta as 15 over 75, and when we reduce this we get 1 over 5 radian. Correct? So this is the second part as well. Now let us try and do this for the third part as well. Correct? For the third part, we have L as 21 centimeters and the radius as, just let me verify if I'm visible right here. Yes, it's working fine. Can move on. 21 centimeter and the radius is again 75 centimeter. Correct? If we simplify this, we get 7 over 25 radian. Correct? So our question number 7 is also solved. So we have, let me just verify. Yes, we have completed all the questions of exercise 3.1 now. Let us try and move to exercise 3.2 and solve the question of that as well. Right? So we are now going to solve exercise 3.2 as well. Correct? Question 1. So in question number 1, in the first part of exercise, in the first part of exercise, we are required to find out all the trigonometric function measures when we are given only one measure and the quadrant in which it is located. Correct? So first question says that cos x is equal to minus 1 upon 2 and x lies in the third quadrant, right? And what we are required to do is we are required to find out the measure of all other 5 trigonometric questions, functions, right? So the simplest thing to do is when we are given cos, find out sec, because sec is nothing but inverse of the cos function. Correct? So sec x is equal to 1 upon cos x, and it is nothing but 1 upon 1 minus 1 by 2, that equates to minus 2. So you have solved for sec, right? Let us try and find out all the remaining 4 degree, all remaining 4 trigonometric functions, right? So we have sec now. We also have, we can now find out sin x. We know that sin square x plus cos square x is equal to 1. Correct? Plug in the value of cos square x into this equation and find out the value of sin x. Correct? We have, let us denote sin square x by x square. Correct? We have sin square x plus cos x is equal to minus 1 by 2. So cos square x is 1 by 4 equals to 1. So x square is equal to 3 by 4. Correct? And x equals to root 3 over 2 plus minus root 3 over 2. Now here comes the interesting part. The absolute value of the sine function is very easy to deduce given the cos function, right? But the tricky part comes in the sine, in the sine of the sine function. Correct? We know that x is located in the third quadrant. Correct? So by that assumption, we can say that when the angle is in the third quadrant, cos is negative, sine is negative, only tan and cot are positive. Correct? So we get sine as positive root 3 by 2. Correct? We now have sec, we now have sine. Let us find out cosec. Right? Cosec is nothing but 1 upon sine. Correct? So that comes out to be 2 upon root 3. Correct? Now we have cosec as well. Let us try and find out cot and tan, and our question would be over. Correct? So tan x is nothing but sin x upon cos x. Correct? and sin x, we have already solved sin x. So sin x is, oh sorry, I'm actually so sorry. I told you that sin x is positive, but because the angle is in the third quadrant, sin x is actually negative. So that is where I made a mistake. So kind of try to forget that. The sin x measure is minus root 3 by 2. Because x is located in the third quadrant, the sign of the sign is negative, correct? It's not positive, sorry. It was a blunder on my part, right? So tan x is nothing but sin x upon cos x, correct? Sin x is minus root 3 by 2. Don't forget the sign here, or you'll get, if your answer will be wrong then. And cos is minus 1 by 2, correct? So half and half gets cancelled, and tan is just root 3. Tan is just root 3, correct? Positive root 3, mind you. Cot is nothing but inverse of tan. So that is how we're going to find cot as well. Right? We have cot x as 1 over tan x, and that comes out to be about 1 over root 3, correct? So we have solved all the values. We have found out all the trigonometric functions values in the first part. Let's try and move on to the second part, and we'll try to kind of get faster as we go on the parts, because we are going to solve it again and again. So we'll make our calculations go a bit fast, correct? The second part, sin x equal to 3 by 5, correct? So we're given sin x. Let us first try and find out cosec x, because cosec x is nothing but inverse of sin x, right? So we know cosec x equal to inverse of sin x, that is 5 by 3, right? So we have found out cosec x. We'll now find out cos x, right? We know that sin square x plus cos square x equals to 1. So we know that cos x is nothing but plus minus 1 upon 1 minus sin square x, correct? So we know cos x is under root 1 minus 9 by 25, and when you subtract 9 by 25 from 1, you get 16 by 25, and you take the root of that, cos x comes to be plus minus 4 upon 5, correct? That is what cos x is. Now here comes the interesting part once again. We know that sin x is 3 by 5 and x is in the second quadrant, correct? So in the second quadrant, sin is positive but cos is negative, correct? So cos x is equal to minus 4 upon 5, correct? Now we have solved for cosec x and we have also solved for cos x, right? Let us try for sec x as well, because sec x is nothing but inverse of cos x, correct? So sec x is equal to 1 upon cos x, that comes to be minus 4 5. So cos x is sec x is 4 upon 5 minus 4 upon 5, correct? That is our sec x. Let's try to solve tan x for this question as well, correct? Tan x equals to sin x upon cos x, and don't forget the signs here, else your answer will be wrong, correct? So sin x is 3 upon 5 and cos x is minus 4 by 5. So tan x is minus 3 by 4, and for cot x we have 1 upon tan x, correct? So cot x would be minus 4 upon 3. So we have again solved and found out all the answers for all the remaining 5 trigonometric functions, correct? Now In third part of the question, we are given cot x as 3 upon 4 and x is in the third quadrant. Correct? Let us try and find this out. This is going to be interesting. So tan x, let us first solve what is tan x, right? Tan x is nothing but 1 upon cot x. So we know tan x is 4 by 3, correct? So this part is solved right out of the gate, right? So we know tan x. Here comes the interesting part, correct? We know, first of all, we need to find out the answer for all the other remaining trigonometric functions. In the previous two functions, we were given the value of sine and cos. So the process was simple. Now we need to apply another trigonometric identity here to kind of solve this, right? Because we are not given the measure of sine or cos. So let us try and do that. We know that tan x is inverse of cot x, which is 4 by 3, right? But we also know that 1 plus tan square x equals to sec square x, correct? So let us try and find out the value of sec x from this equation, correct? So 1 plus 16 upon 9 equals to sec square x, correct? And for that part, so we now get sec square x as 25 upon 9, correct? Now let us take the root on both the sides. So we get sec x as plus minus 5 upon 3, correct? Now how are we going to find out the sign of sec x? We know that x is in the third quadrant, and in the third quadrant tan and cot are positive, else everything else is negative, correct? So we get sec x as minus 5 by 3. We have sec x, now we have tan x, we have cot x as well. Now it is very easy to find out the remaining values, right? So I'll do that in one go and we can move on then. We are going to now solve for cos x. So cos x is nothing but 1 upon sec x, correct? And 1 upon sec x is minus 3 by 5, correct? Similarly, we can solve sin x as well. We know that sin x is nothing but under root of 1 minus cos square x, correct? And we also know that it's going to be negative because it is in the third quadrant, right? So let us put the sign so we don't forget, right? So we'll get minus under root 1 minus 5, upon 25, and we get sin x as minus 4 upon 5. When you're going to solve this is what you're going to get, correct? We have sine, we have cosine, we have cos x, we have sec x, we have tan x, we have cot x. So cosec x is nothing but 1 upon sine x, and that is nothing but minus 4 on 5. So minus 5 by 4. If again solved and got the value of all the remaining trigonometric functions, correct? Let's try and move on. In the fourth part, we are given sec x as 13 upon 5, correct? So cos x is inverse of sec x, so that is 5 upon 13, correct? Let us first solve that. Tan x is nothing but sec square x minus 1 under root plus minus, correct? So plugging the value of sec x as 13 upon 5, we get 169 upon 25 minus 1 under root plus minus. That is the value of tan x, correct? And when you solve this, you get tan x as plus minus, you get tan x as plus minus 12 upon 5, correct? But we know that x is located in the fourth quadrant. So we also know that the value of tan is negative in the fourth quadrant, right? So tan is minus 12 upon 5, and consequently cot x is, sorry, minus 5 upon 12, correct? Now we need to solve for sin x as well, correct? Sin x is under root 1 minus cos square x plus minus, correct? We also know that the x is located in the fourth quadrant, so sign is going to be negative, correct? So no point in putting plus minus. We know for a fact it's going to be negative, right? So we get negative 1 minus cos x is, so we'll write 25 upon 169, and when we solve this, the answer that you're going to get is sin x is equal to minus 12 upon 13, correct? We have got cos x, we have got cot x, we have got tan x, we have got sec x. All that is remaining is cosec x, and cosec x is nothing but inverse of sin x, correct? So cosec x equal to 1 upon sin x equal to minus 13 upon 12. That's it, we have solved all the parts, correct? Moving on to the fifth part of the question. We are given tan x as minus 5 upon 12, correct? And x is in the second quadrant, correct? When we are given tan, start with cot, because cot is nothing but inverse of tan, correct? So cot x comes out to be about minus 12 upon 5, correct? We have got cot x. Let us solve for sec x, because we have tan x, so we can solve for sec x, because we know the identity sec square x is equal to 1 plus tan square x, correct? So we'll now solve for sec x. Sec x equals to 1 plus tan square x under root, correct? 1 plus 25 upon 144, correct? So that is 169 upon 144 plus minus, correct? We know that in the second quadrant sec and cos are negative, correct? So we know this minus 13 upon 12. We are given the value of sec x, so simply cos x equals to inverse of sec x, and that is minus 12 upon 13, correct? Applying the identity that we have learned, that sin square x plus cos square x equals to 1, we can solve for sin x as well. So sin x equals to 1 minus cos square x under root, and we know that x is in the second quadrant, so sign is going to be positive right here, correct? So we'll get 1 minus 144 upon 169 under root, and sin x comes to be 5 upon 13, correct? We have sin x, so cosec x equals to 1 upon sin x, that is 1 upon 5 over 13, correct? So that is our answer, right? We solved, we found out all the values, all other values of trigonometric functions, correct? Solved the first 5 part of the questions, right? For the parts that are now remaining from 6 to 10, we need to find out the values of the trigonometric functions when the degree measures in the sine function or the cos function or the cot function or any other function for that matter is not in the range from 0 to 360, 0 to 360, right? So for this particular question, what is required is that we need to remember all the periods of each and every trigonometric functions. Just for reference, I'm going to write out for sine, cos, sec, and cosec. The time period for these functions is 2 pi, correct? And for cos, and for cot and tan, the time period for these two functions is just pi, correct? Basically what I'm saying is, if you represent either of this function as, let us take the example of sine 2 pi plus x is equivalent to saying just sine x, because the function repeats after a period of 2 pi. After a time period of 2 pi, the function tends to repeat the values, right? That is just this. And for this part, if I write cot x as cot x plus pi, the meaning does not change. It remains cot x, because cot and tan have a period of pi, correct? These are the things that we need to remember before solving these questions. Let us quickly, at a glance, solve this question, because these questions inherently are very easy and we'll be able to solve them pretty quickly, right? Sorry. So in question number 6, we are required to find out sine 765, right? We know that 2 pi, first of all, we should know that 2 pi is equal to 360 degree, correct? Can we write this as sine 720 plus 45 degrees? We can do this, right? We can break this 765 degree into 720 plus 45 degree. And we also know that because the time period of sine is 2 pi, after the interval of 2 pi, the values start repeating themselves, right? So this 720, we can neglect that. We can just express this as sine 45 degrees, correct? And we know the value of sine 45, that is just 1 upon 2, correct? That is our answer. Let's try and move on to the next part. Question number 7. Cosec minus 1410 degrees, correct? Now, we first saw that how we could kind of break apart the degree measure in the sine function, right? But the another thing that we can do is we can also add an interval of 2 pi to kind of solve our question, right? We can add the time period in the function because the values repeat, right? So for example, we can represent cos x as cos x plus 2n pi. This won't change the function itself, right? Because the time period is 2 pi, we can represent cos x in this format. We can add 2 pi as many times as we like to kind of solve our question faster, right? So let us try and do that. Let us try and bring this value in the range of 0 to 360, using which we'll be able to solve this, right? Let us try and add 8 pi to this function, right? So cos x can also be written as, this can also be written as minus 1410 plus 1440. This right here is nothing but 360 into 4, and this right here is nothing but 2 pi into 4, right? So what I've done is I've added the time period 4 times into the value, into the input value of this function, right? That is what I've done, correct? That won't be wrong, correct? So 1440 is added, and minus 1410 plus and plus 1440 reduces to positive 30 degrees, and we know the value of cosec 30. Cosec 30 is nothing but 2, correct? Simply that is something that we have done. So question number 7 is also solved. Then we are required to find out the value of 19 pi by 3. 19 pi by 3 can also be written as 18 pi by 3 plus pi by 3. Correct? 3 and C gets cancelled because it has a time period of pi. 6 pi by 3 plus pi by 3 can also be written as just pi by 3. And we all know the value of tan pi by 3, that is nothing but root 3. This question is also solved. Correct? Next we have question number 9. Sine minus 11, sorry, minus 11 upon 3, minus 11 pi by 3. Correct? Let us try and again do that what we did in the previous part, where we added intervals of 2 pi into the input of the function and kind of got it in the range of 0 to 360 degrees. Correct? So we'll do that once more. Let's try and add 4 pi into this equation, because we can do that, right? We can add any multiple of time period. I'm reiterating this one once and once again because students tend to get confused that how we got this function, how we got this value at the end, right? We can do that. We can add the time period of any function to its input values and the answer won't get changed. Correct? So we'll do that once again. Sine minus 11 pi by 3 could also be expressed as sine 11 minus 11 pi by 3 plus 4 pi. Correct? And 4 pi in itself could also be written as 12 pi by 3. Correct? So that is nothing but, when we add these two values, that is nothing but sine pi by 3. And we all know the value of sine pi by 3, that is root 3 by 2. Correct? So that is also solved. Moving on to the last question that we have for the day is, we required to find out the value of this function right here. And to do this, I will again try to get this in the range of 0 to 360 degrees or the time interval of this particular function. So we can kind of add as many time interval or time period into the input value of this function as we want to kind of simplify our task, and that won't change the final answer, right? So let us try and add a value of 4 pi into the input of this function, and let us see what happens, right? So it won't be wrong to express this as minus 15 pi by 4 plus 4 pi, and it also won't be wrong to write 4 pi as 16 pi by 4. When you add these two values, what you are left with is cot pi by 4. We know the value of cot pi by 4, that is nothing but 1. Correct? So that is our final answer. So we have solved exercise 3.1 and exercise 3.2 in this particular class. In the next session, we'll try and find out all the uses of trigonometric functions. We'll also try and recollect all the trigonometric formulas that we remembered in our class 9, and we'll kind of add more to that, and we'll see their application in our next exercise, right? So that is all for today. Thank you.